Hi everyone, welcome back to my channel. In this video, I am going to introduce one of the most important oxidizing reagent, that is mCPBA, that is also called as meta-Chloroperoxybenzoic acid. This one reagent we can use it for countless oxidation. Let's meet mCPBA. This is useful for CSIR NET to get IIT JAM and for MSc examination also, and also it is most important for pharma industry interview. Now let's see what is the useful of this reagent. What it does. mCPBA. This is also called as meta-chloroperbenzoic acid. Here you can see the structure of the chloroperbenzoic acid, and it is useful reagent for the formation of epoxides from alkenes. So we can use it for the alkenes epoxidation. We'll see. Next we will see mCPBA is a peroxycarboxylic acid that is commonly used as an oxidizing agent. Here in this structure you can see the peroxy group C double bond OH. So this is the peroxy group, and it is usually available in 77% form because pure mCPB is a shock sensitive, potentially explosive. It usually consists of 10% meta-chlorobenzoic acid and the remaining is water. Now we'll see the examples. First example is epoxidation of alkenes with peroxy acids. Here you can see the example of alkene, and that is treated with peroxy acids. You will get a epoxide. And another example you can see the cyclohexane, that is treated with mCPB. You will get a epoxide of cyclohexane. Now let's move to the another concept, that is when alkenes are treated with peroxy acids such as meta-chloroperbenzoic acid, two new CO bonds are formed and a CC pi bond is broken, that is resulting in the formation of epoxide. In this reaction, an OO bond from mCPB from and an OO bond from mCPB is also broken, which is the source of the oxygen in the epoxide. The byproduct in this reaction is meta-chlorobenzoic acid. This in this explanation talks about mechanism of mCPB reaction. Next, we'll see the stereochemistry of mCPB reaction. Epoxidation of alkenes with mCPBA is an example of stereospecific reaction. So, in epoxidation reactions, the configuration of atoms about the alkene is always conserved. Let's see the example. See, for example, the trans alkene below gives only the trans product as an equal mixture of enantiomers. So, trans alkene always gives trans product. Here you can see the example. Here, when alkene treated with mCPBA, here two enantiomers has formed. So, trans alkene always gives trans product, and this stereospecific product will form. Now, likewise, the cis alkene gives cis product, only product B. The trans product A is not possible. Here you can see the example. Here two hydrogens are cis, that is cis alkene. When treated with mCPA, you will get directly B, not A. A because cis alkene always gives cis product. Next, we'll see other epoxidation reagents. Except mCPBA, other uh, epoxidation reagents also cause epoxidation. Now see what are those. Other peroxy acids have been used for epoxidation reactions such as peroxyacetic acid, peroxybenzoic acid and trifluoroperoxyacetic acid. Here you can see the structure of those reagents. Peroxybenzoic acid, peroxyacetic acid, trifluoroacetic acid. And one more is dimethyl dioxide, DMDO. This is also one of the most important reagent for epoxidation. Okay, now we'll see the useful reaction. Other than epoxidation, you can see other useful reactions also. One is epoxidation of alkene. Alkene to epoxide will form. And another one, this mCPBA can be used for Baeyer-Villiger oxidation. In that reaction, you can convert to ketones to ester. In my next video, I will talk detailed about Baeyer-Villiger oxidation. Now we'll see the next reaction, oxidation of sulfide. When you do sulfide oxidation using mCPBA, you will get sulfide, that is S double bond O, and further treated with mCPBA you will get sulfur, that is SO2, S double bond O, S2 double bond O. Now next move to the, now in this reagent also used for N-oxide formation. See, you can see the example here. Substituted pyridine they have given. When it is treated with mCPBA, you will get N-oxide. Like this, for oxide, see N-oxide formation is oxide formation. For these particular reactions, mCPBA is one of the major reagent. Now we'll see why and how to quench mCPB. Actually, this is most important for pharma industry interview. See, mCPB is why we have to quench mCPB. See, mCPB is a strong oxidizing agent. Even after your desired reaction is complete, leftover mCPBA can continue oxidizing and your product or create your that leftover mCPBA can continue oxidizing your product or create safety hazards. Quenching destroys the remaining oxidant, so stopping the reaction and making the workup safer. So now we'll see what are the common quenching agents used for mCPBA quenching. One is aqueous sodium sulfite, Na2SO3. This is the most commonly used quenching agents, and another one is aqueous sodium bisulfite, NaHSO3. This is also effective, and sometimes we can use sodium thiosulfate also. These reducing quenching agents convert the remaining per acid into non-oxidizing products and preventing further oxidation. I hope you understood this concept. In next video, I will come with another most important oxidizing reagent. Thank you. Have a good day.